Hello and welcome, dear viewer, to another video about powder. Today I'm also playing piano for some reason. However, what I'm doing today might be a bit boring. Maybe, I don't know. I can't judge what is interesting in these videos. So the thing is, I originally wanted this episode, which I believe is the 5th episode, to be about arithmetic expressions, something like 0 plus 7 times 8 minus 4 times, I don't know, 14 divided by 6 or something like that. You know, arithmetic expressions. And thing for that is because of operator precedence. So of course, multiply and divide has precedence over addition and subtraction. We need to be able to backtrack. Basically, we need to, or the simplest way to implement that is to always try and parse a divide or a multiply first. So let's do another example here. If we have something like 5 plus 6 times 8, we of course have to make sure that 6 times 8 is an inner expression and 5 plus whatever else is the outer expression, so that operator precedence is kept. And I believe the simplest way of doing that is always try and parse multiplies and divides first, and if that doesn't succeed, parse anything else. So basically in this case we would parse 5 and then the plus, so we have an addition operation with 5 as the left side, and then the right side, the entire right side, is then parsed recursively, essentially, because we have like left associativity. And before we try anything else with this side, we will try and parse a multiply expression, because if we have something like 6 times 8 plus 9, for example, we have 5 plus whatever's on the right side, and we want to make sure that 6 times 8 is grouped together, because if we do the same thing as we did before, we will get 6 times whatever is on the right side, and that is not correct. So we first need to try and parse the multiply here. So we get 6 times 8, and then we can parse further. However, if that doesn't succeed, like in this case where we don't have a multiply, we need to backtrack and parse an addition or subtraction instead, which means backtracking. I was very lucky last time, actually. That was kind of intentional, but all of these things here, like these very simple statements and expressions and stuff, can all be parsed strictly forward, because there's basically no alternative. If we don't have something that we currently support, we just crash or print an error. We expected something else than was actually there. However, if we want more complex things, of course, we need to be able to backtrack with a parser and like try to parse something that we think might be there. And if that doesn't exist, there might still be something else valid. So we need to backtrack and try that instead. For example, if we don't have const or var here as the first variable, we for example might want to try parsing a function, for example, function call. But also if we have something like this, an assignment, there is both an identifier in this kind of statement, and there's an identifier in this kind of statement at the beginning. So if we parse the first identifier, we don't know yet if we're going to get a function call or an assignment. And so we need to be able to like look ahead. Okay, if there's brackets, then it's a function call. If there's an equals, then it's an assignment. And if that's not the case, what we expected, we need to backtrack and try the other thing. So that's the main issue that we're facing right now. So before I do anything else, I want to actually rewrite the parser in a nicer way. So we'll also we'll get rid of this. We'll wrap that in our own thing, our own struct, and also the next token thing. I didn't like that last time. I'm going to throw it away now. Basically, if you have like a token already parsed accidentally, quote unquote, you can like backtrack the parser one token and just handle that token again in the inner function that you're calling. Like for example, the parse expression. I don't actually know where that is exactly called. Yeah, well, for example, in this case, like we don't even care what's there. We just take something because we need like this first expression to be parsed as a function here. And yeah, it's silly. Like don't just no. Let's make this nicer. Okay, so let's create a parser. What are we going to call this? Not parser, but like token stream. Token stream is a built-in name in Rust, so I don't know if we can actually use that. Can I do this? What does it tell? Yeah, okay. I'm just gonna call it token. I think token stream, it's somewhere in the Rust standard library because for some kinds of macros, you get like the Rust token stream, but that's actually not backtrackable. That's just an iterator basically over Rust tokens. Yeah, but that's not something we have to worry about here. So let's derive debug immediately. Going to definitely need that. So the token stream contains the actual token iterator. However, I think I don't want to actually store like an iterator. I want to store a list of tokens like we get here instead. And maybe I actually want to like have this token stream own the tokens. Yeah, that would be a good idea. And maybe it should also own the code, because then it can just be independent. Wait, let me check the main file. Yeah, so currently the tokens like depend on the existence of this code variable because they all just have essentially slices into the code or like have a reference to the code and then indices to see where the actual data is. So it would be nice if we could like bundle that up with the token stream. Now that will cause a self-referential struct. So a struct where one element references another element. And that I can tell you right now is a big problem. Like Rust doesn't support that right now. The borrow checker is not smart enough for that. So we need a special package for it. That would be the simple solution. Maybe not the simple solution. That would be the correct solution. Or we can just ignore that problem for now and not include the string here. Okay, let's not include the string for now. Let's put in a to-do. To-do. Include the code string with this struct. Oops. That makes it self-referential, though, so we would need Boros, which is I think that's Oru. Oh god, I don't know how that is spelled exactly. Like that's a Rust crate that does the self-referential stuff for you with like unsafe hacks. And Ouroboros, or I don't know, I'll put an image on screen. That's like a mythical snake or something that bites itself into the tail, so it's self-referential. That's kind of the joke here. Anyways, let's not worry about that too much right now. Let's just have the tokens, which is a vec of token. Okay. Yeah, right. So now this needs to have a lifetime because now this token stream needs to live as long as the code that all of its tokens are referencing. And also this way, like we enforce that all the tokens reference a string with the exact same lifetime, which is also kind of nice. So we need to, of course, have an index. And I think that's all we need for now. Let's import token stream. Let's already wait. I always forget. Yeah, that's the way. Okay. Okay, so we can pass in a vec of token, which gives us a self. And this will return a self with tokens index of 0. And then we can do the other thing and like write a simple next function. So let's do the option of token thing. Or maybe no, actually, because we're always like doing result stuff anyways, like okay, or like this is very much annoying me, this is very repetitive. Let's actually have that return in a result already. So, and this also returns something that that is like, that's a contained token. Yeah, because yeah, it's a copy of the internal token, because tokens are really cheap to copy. But like the string that this token is referencing is still the same thing, so it still has the same lifetime. Oh, is it just complaining about? Yeah, it's just complaining about the that there's no return in here. So let's actually, yeah, now we need a now we actually need an error message. Wait, let me actually handle the lifetimes before I fix this. So oh, I need to, yeah, this is kind of silly. I need to put that here. So if we if you give me a string of this lifetime, wait, I don't need, oh, I don't, okay. Yeah, I think that's handled automatically, I believe. So basically what I wanted to say explicitly to Rust, hey, this error message has the same lifetime as the string that I'm returning, because I'm literally returning this exact same thing. But I think I don't need that if I'm just moving the string around, which means that its lifetime gets extended automatically. Like, yeah, I think that should be fine. So let's try this. Function next. So we need to self this one. I'm going to need a length function. Which simply returns tokens.length. Okay, if self.length is if index is greater than length or equal to, then we'll error, else we'll okay with the self tokens. Oops. Great. Yeah, so that should do the error handling for us. So we can just like pass in the this string into the next function, and it will just return that. And then we can question mark operator that, and yeah. Okay, we'll need backtracking in a moment, and we'll need like state recovery things and so on in a moment. But let's start out by actually passing in the token vector in here. So equals token stream new tokens. And also I was just noticing, like, you know how we only handle comments in here and not anywhere else? Like, we can just handle comments in token iterator.next. So yeah, basically I can just do while self.index is less than self.length and self.tokens index self-index dot type is not equal is equal to that needs to be a do while loop. Does that even exist in Rust? I don't even remember. There's no do while loop in Rust. Interesting. Okay, let's, in that case, wait, equals token type dot comment, first of all, not dot, colon. Yeah, so like that. Okay, so basically if we already got past the end here, we won't do this. So yeah, just go in here and return an error. But if we're still fine, then we can check the type, and if it's comment, just skip it. And do that as long as we have comments. So basically we can we can do yeah, we can transform this while loop into a slightly different form, and for that I will need another helper function. We need isEnd basically again. So self.tokens length self.index so then I can also make use of that here. Just, yeah. Let's hope that the Rust compiler is smart enough and like inlines all of these, because they're really tiny functions. I don't know if there's like a way to force them to inline. I think I can const the I can const the function. Right, I can const basically probably this one. I can const that function. Or am I just, or is it just not complaining right now? That might also be the case. But know that like const function definitely tells the Rust compiler that there can be a bunch of optimizations done on this thing. Yeah, so anyways, so basically this is while tokens dot isEnd, so not isEnd. Parse definition tokens. And now what we take here instead is, in all functions, we will take tokens, which are, let's call them token iterator so that I can do a rename. Iterator, which is just a token stream a reference to a token stream. Because yeah, that can just live up here and we reference it everywhere. So yeah, this is all this is pretty ugly actually. Let's just like transform all of these into their new form. And now I could, yeah, that should actually be it. Like, oh, okay, so I can, like for convenience, let's have and stir here. Just use to own down here. Yeah, that's actually super cool, because if we don't need the error message, we will never create like an owned copy. So yeah, so that's super sick. And we need to do that here as well. Also, we don't need to do that here because we're going to rewrite parse block in just a second. And now we need to actually, okay, so let first token equals the token iterator next. Okay, and then we have to first token here, else this is first token, and we can throw all of this out. We can just tell it to parse the statement. This is all fine, open bracket. Yeah, we extract the function name, the first bracket, the closing bracket, and then take the curly brace and then construct this function AST element. Okay, cool. So we can just remove this and take as the token. And I'm just noticing that these are all mutable references. Yeah, I can just do that. And I think we can delete that. So we, yeah, in this case, we can just token iterator next expected open curly. Maybe peak. Yeah, here we go. We do some peaking, I think. Expected something. Oh, that's great. I don't even remember that. It has only been like 2 days ago that I did the last episode, so yeah. So, oops, that was the microphone. Let's try, and I'm just thinking through this code because we have a peak here. So if the peak is not a close brace, then we parse a statement and then peak the next token. Okay, chill. I think I'm going to generalize this into a helper function. Actually going to move like all the const accessors up here, and then we have down here the more complex functions. So let's do a function that is called look ahead, because that's basically what it's doing. Can look ahead any arbitrary size. And it also takes an error message, and it returns a result of either a vec, now in this case, I think we want to actually like return a token slice from our internal vector, so that we don't copy for every look ahead. That would be rather nice. So this should be fine. Yeah, okay, it's fine. So let's close this down a bit. Look ahead. Okay, so don't want to call next in this case. Okay, so if self.isEnd or self.index plus amount is greater than or equal to the length. I'm just gonna bracket this for safety, then we will error out. That's a cool thing. Now we can like immediately check whether this amount is too much. Else we will okay with the tokens from self-index self.index plus amount. This gives us a, yeah, okay, so we just have to reference that. Cool. I hope that that's, wait, I can also just, maybe that's even cleaner. I can just get this, because like the get is the safe variant of the index operation. It will tell you in a second. Yeah, right. It returns you an option, which you can then check for. Just it's okay, or I think that's all I need actually. Yeah, okay. Sick. I can just wait. And then I can just and wait. I'm just thinking, I think like this is like, we don't need the check, because like get performs all the checks for us. So I think that's, yeah, that's perfectly fine. Okay, yeah, so cool. I can just do a look ahead. I don't think even we need like, I think if we program this well, we don't even need like we don't even need backtracking, because if we know, okay, we need to look ahead this many tokens, and to determine what the next elements are, then we don't need a backtrack. And I think like that's something that parsers in general can do. Like there's parser categories. You all see that on screen right now. And you can categorize parsers depending on how far they have to look ahead. And I think a Powder can get away, at least at first, with a look ahead one parser, which I think is called an LL or LR1 parser, something like that, which in general means better performance for the parser, because there's only so many options that you have at any point, and you'd only have to like look ahead and then go backwards in a sense that many times. And there's more complex languages that need a lot more look ahead. Though that's just like me speculating. I've only recently learned about the entire like categorization things. So yeah, take it with a grain of salt. And okay, so here we go. We can just look ahead 1. Expected statement. So yeah, map or. Map or will tell us, can just index 0. Yeah, we still want to do the map or here. So if we have a if we have something, if it's the word provided default, returns to the provided default or applies a function to the contained value. Yeah, so if we have nothing, we're going to return false, so we're going to bail out. If we have something, then we're going to check that it's not a brace. Yeah. Okay, so this is still the same. This is actually cool. So I very smartly designed this this thing so that we can just reuse the same code. Okay, so we can just parse statement with the token iterator and don't need this. Wait, we do need it because we need to look ahead. 1 expected statement. I think we're going to throw away the error actually. So yeah, I think there's some issue with error reporting here, but I'm not going to worry about it right now. So parse statement is next. So we can just put the token stream in here. Remove that. And yeah, so parse other statement types. So for example, here, the kind we want to like, depending on the type, like we can do a look ahead here. And for example, if we see a const or a var, we have a variable declaration. If we instead get basically anything else, as far as I know from the AST last time, let's check the AST actually. Any other thing is an expression at this point. And I think that will actually stay this way. Like, I want as many things as possible to be expressions in Powder, because that's a super, as I said, like in the first or second episode, that's super composable. Like you just get things for free, literally. Like you can just implement if as an expression, and you get if both as a statement, like conditional block, and you also get like a ternary operator, quote unquote, for free. With that. So that's why I don't think like statement will change in any way, except for like what the variable declaration contains. Like there might be more things in here, or like more, though their kinds might change. But the expression, I think, yeah, that will stay. So basically, if we can't parse a const or a var, we will just try and parse an expression, and then we can, and then we also have to parse a semicolon at the end. So yeah, that's that. Yeah, but for now, I'll not do this in this episode. We might do that next time. So for now, I'll just iterator next expected expression statement. Okay, or else actually let's write a new helper for that. This is in Lexer, I think. Here we go, yeah. So we have token type slice, we get the same thing. So if types dot contains self type, I think we can just do that. Okay, self else expected any of, and we can do that. And we have to borrow that. Cool, that was actually super simple. Now we can just basically just pass a slice const. Yeah. And we don't have to map the error because that will just give us, yeah, so it will just give us the error already, like what we want, expected any of, and then we'll have like const comma var in here somehow. Yeah, so I think that's fine. So we can just now just do the conversion. I think this will crash, or like this will not be correct in most cases. So yeah, in this case we need a look ahead. Index 0, expect token type equals. Yeah, I think we can just do this. Because that shouldn't crash. Like we just looked ahead one, so next shouldn't crash. So expected type. Yeah, we have like this .next.expect pattern. Maybe I'm going to consolidate that in the future as well. That'd be nice. Wait, no, we don't need that. We can just pass the thing normally. Now we want to get a semicolon. Next. Where's this complaint? Oh, right. Yeah, because yeah, it's the same thing as above. We can be sure that there's something there. Okay, so parse expression, the last one, the very last one. Let's take token stream again. So yeah, so now this is what we'll look at in the next video, where I need to do quite a lot of look ahead to figure out what exact expression we get. Like for example, if you have an identifier, as I said beforehand, you might have a function call, or you might have just the identifier itself. In this case, it's like a variable name lookup thingy, and then you might want to look at then you have to look at the multiplication or addition, like operator precedence. You need to look ahead at least 2 tokens for that, I think. So, or I don't actually think you have to, but you definitely have to look ahead 1. So yeah, token iterator next. Oh wait, look ahead. Expression x0 type, and then we can just give you that. Then we can just okay. So okay, so now we need to actually token iterator.next. And next down here. Expect literal for now. Okay. And that can actually just be collapsed into, oh, it actually wants to have it that way. Okay, cool. I guess so. Now do we have any more errors? No, we don't need peekable anymore. That's a good sign. Now what does main complain about? Oh, yeah, it wants to. Now we actually obtain the tokens. That's cool. Okay, so this can't be const, in fact. So this also can't be const. Okay. But I guess new can be const, just kind of nice. We don't need it, but maybe some optimizations are done. Yeah, okay, so let's go into the powder bootstrap. So let's wait. Here we go. Oh, okay. I didn't actually look for all the errors here. First borrow might be used here when maybe peek next is dropped and runs the destructor. Fuck. What is this? Yeah. Second mutable borrow is in line 100. Wait, let me look at the error in the console. Yeah, okay. First mutable borrow occurs here, maybe peeked next. So look ahead here. Because, yeah, that returns, though that is not a mutable reference. Is that not clear to Rust? First mutable borrow occurs here, second mutable borrow occurs here. First borrow might be used here, and maybe peek next is dropped and runs a destructor for this, though, yeah, because it can't figure, wait, no. Now this is interesting because we know that because this is not an owned value, it can't actually like run the destructor for, like the destructor, running a destructor for a slice is pretty much a no-op, except for like marking the memory as free to use. However, I think that's maybe because of the string, because like running a string destructor, that's actually a operation that is more involved, that actually deallocates and like deletes the stuff. So yeah, I cannot borrow a token iterator with mutable more than once. Okay, I'm trying to think if that is like an actual problem with like a use after free. Like, yeah, because mutable borrows and like double mutable borrows are, I think, no, it's not about use after free. This is not about lifetimes. This is just about about making sure that nobody does modifications at the same time. Though, of course, that shouldn't be an issue here. So let's see. So look ahead modifies the, yeah, okay, so maybe peak next. We have to do that in some fashion, because look ahead well, why is it important that this string destructor runs? Because first borrow might be used here. Okay, yeah. Yeah, that's absolutely a case of like Rust doesn't understand that the referenced type in here is not like it's not modifying the original type. Like this is not like destroying this slice, which is a slice into token iterator, which is like taking a reference that points back to the token iterator. Like that is destroying this slice has nothing to do with the token iterator, because it's literally just a marking memory as freed. But Rust can't figure that out. Rust thinks that through this reference, we're running a destructor on token iterator somehow, which of course would be unsafe here. Like, of course. But yeah, so that's a problem. Okay. I think I need to copy then. Like that's I think the only way out. Cloned. Okay, I can't clone something that is unsized. Okay, I have to, and then probably calls op if the result is okay, otherwise returns the error value. Yeah, okay. And then take the look ahead, like the peak next, and return the peak next index 0. And then I have to, I think like Clippy will tell me a better way to do this in just a moment. And then I can actually remove the index 0 here. And now this should be a copy, like peak next should be, yeah, result of, and then we have to do the exact same thing down here. But now we're basically extracting the token and taking a copy, which I'm guessing is fine, like for memory usage. Oh yeah, and we can just use map, I think. Yeah, we can just use map. That's what I was saying. Like Clippy will yell at us immediately. Yeah, okay, cool. This is probably a bit less performant, but it should be fine. So what do we have here? Use okay or by a function, okay or else. Okay. So this is always run right now. So if I do okay or else, it will actually only try and copy the string if it's an actual error. That is, thank you, Clippy. Like it's not a big deal probably, but still, more performance for free is always good. By not writing crappy code and stuff. Okay, I think we got the borrow checker now. So let's try. We're messing something up here, though. We're Very good. Function identifier, blah, 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 colon, n64 equals semicolon. So the first type that we check for after the equals, open brace identifier, yeah, we're still in this line. So the first one we check for is a semicolon, and that is, yeah, I can just search for that. Expect, wait, token type semicolon. Okay, here we go. So if we get the type, check for n64, and then if we have an equals, we check that here, we skip it, we parse the expression, okay, why is it not? Okay, we should use if let here as well. If let, okay. Equals this dot expect. Especially then it will like show up in our debug log. We're never checking for plus. We're never calling parse expression. Maybe I want backtrace. There's one. And I did the mistake again. Okay. Wait. Oh, it's suggesting me to click on this. On the crate emoji. Anyways, okay, where are we? Main. Okay, right. We don't get get a trace back for that. So I guess that doesn't help us. Okay. So why is this happening? We're checking n64 equals. Checking for type equals. And if we find an equals, that should say equals. Expect token type equals. Skip that and parse the expression. That's actually just we're never parsing an expression. That's chill. Why are we not doing that? The only reason I can think of is that we don't find the equals. N64. Checking for type N64, checking for type equals. Debug. Okay, so we didn't find an equals. Yeah, we didn't find an equals. Oh, that is just great. What is the look ahead doing? My God. Can I just inspect that? Let's just do this thing. debug. Okay, of a token that is ends. Okay. Wait, so let me see here. Checking for type. Open brace, look ahead. Then we have identifier colon N64 look ahead. Where do we have that? N64. Colon expected the type. Why are we checking for the type and then performing a wait? Yeah, I'm this is not correct. This should not be correct. Because we're checking for type and 64 like expected identifier. We're in parse statement, pretty sure. Identifier colon. And then we check for N64 with next. And then the next element we get, like this down here, is executed on this look ahead. We still get the same token. Like, why is it not advancing the token iterator? Doesn't make sense. Does not make sense. Checking for type N64. There is no next token. Let's actually check that the. Yeah. Okay. So the token stream itself is correct. So it doesn't make sense that there's It doesn't make sense, for example, if we were at the end or something. But if we were at the end, we would like print an error anyways. So that shouldn't happen. What the hell? Like what? What? Excuse me. Is look ahead completely broken? Self index plus equals 1. Oh my fucking god. All right. I just found it. We're incrementing the token after the fact. So I think if we look into like what we find here, yeah, I think we're just lucky because the first thing is a comment. Yeah, oh my god, this is dumb. Like we're incrementing the index and then checking like the next element. So like the element we have just incremented to. So what we should do is let current index equals self.index. Okay, first of all, if self.isEnd, then we can already return return error. So the current index is that. And then we store it, like then we advance while the index is a comment and we're not at the end. And then at the end, however, we'll use the current index as an index into the return value. Okay, I think that's it. Not entirely, but for the most part, yes. No, that's not okay. Checking for type function. Expected any of var const. Yeah, at least we know that this kind of works. I mean, wait, let me just. Yeah, because, yeah, so basically like look ahead 1 and next return the exact same value. That's what should happen. However, next increments the index, so the next time we call next, for obviously, we get the token after that. But look ahead doesn't increment it. Let's log the next token thing again. So we get next token. We check for function token type function. That's parser definition is okay. Expected definition. We get that. Function name. Wait, what the hell? Oh, now actually like the parse statement code that I put in last time and didn't get to work. Now this actually runs. So essentially something up here is going wrong. So if the first function, let's actually log what we do have. That will be super useful. Checking for type function, but has comment. Ah, this is actually an edge case that we shouldn't normally hit. I know what's going on. We're just not skipping over the comment when we're starting at the comment. So basically, new. Let's equal self new, and then we need to while new is end and new dot tokens new dot index type is equal to token type comment new dot index equals 1. Okay, sad, but this doesn't really matter. Now I just realized that look ahead is not actually checking for comments. So I think this very, very nice function that we wrote here doesn't work. Or on the other hand, I have a much better idea. Let's just throw out all the comments in the new function and not have to worry about it anywhere else. That's a much better idea. Okay, so we just, and this is actually super quick to do. Tokens dot iter dot filter token dot type is not equal token type comment collect or into from filter of iter slice yeah, collect probably. That should work though. Oh, I need to into iter. Yeah. So I need to own the tokens now, or own the elements of this collection now. Okay. Well, that was fast. So let's do that. And now we can do this. Wait. don't even have to do that. Oh my god, this becomes so clean. Let's just do that. So if we're at the end, then we don't have an element. And this is actually good. I think we would have crashed like at the last curly brace, because we can still obtain the next element if we're currently at the last index. But if we do the check after advancing, then we will of course not be there anymore, except like we can still index. So like if this self.index increment now gets us to self.length, so at like exactly one index past the last element, that's not a problem, because -1 gives us the last element. So that is still fine, like the last time we can call this. So I think look ahead should be fine now. Like why didn't I think of this solution before? This is super convenient. Boom! We have a parse. That was easy. I mean, well, it wasn't easy, but in the end, like, the solution was kind of simple. Yeah, immutable x sum unary plus 78 mutable value none. Okay, let's actually check if I just made global variables work. Const a global n64. Let's just check if I just did that. No. Oh, checking for type function, but has const. Expected any of var const token. Okay, it doesn't work yet, but it should, because it's correctly like checking. Maybe we're just advancing past that element. That might actually be the issue. Let's see, parse definition. First token that expect, else parsed. Yeah. Okay. No. That doesn't work. We need to look ahead here. Look ahead 1, expected definition, then index 0. First token, okay, then we can do the usual token iterator. Next with an empty message. I think that's the whole fix. Let's see. Boom shakalaka. That's our global variables right there for you for free. Oh my god, this is so amazing. Okay, let's 1 hour already. I didn't think that would take that long. Okay, let's end the video here. Like last video was 1.5 hours. That was kind of very long. So let's end the video here by writing some commits and also removing a bunch of the debug logs first. Which ones do we want? We don't want this one. We don't want this one. We also don't want this one. We also don't want these, because that will make our thing much cleaner. Yeah, it will just be like a simple, like this is something you can write in Haskell basically. That's my measure. How beautiful is this code? Basically for me means how much does it look like a Haskell function? Like this, for example. This is super nice. Oh, we're not using debug anymore. Great. Let's get rid of it. The lexer can keep this. Like this is something we want to keep. Let's just for safety check that it still works. I would actually like to know how fast that is. Where's the? Let's go back to Warren. Kind of want to know how fast that is. Yeah, let's write some performance stuff in the next episode. So I'll commit this and commit all of the lexer things. but has, yeah, okay. Expect any, that's good. We don't want this. And like the entire refactor. And yeah, let's actually commit that as well. Bootstrap refactor parser. And the new token stream allows us to easily look ahead and removes all the comments before parsing. This means that comments now work everywhere, and we can parse global variable declarations. Let's see. That's 6 characters. Just guessing. Yeah, okay. Let's commit that. And okay, I guess I'll see you in the next video. Until next time, goodbye.